Hey guys, how's it going? It's getting pretty late, so I'm not going to actually do anything this evening, but I just wanted to let you all know what was going on. So, for somebody that purports to hate uh, breadboard, I sure do have a pretty good chunk of it right here in front of me now, don't I? Well, I'm nothing if not a hypocrite. So, we're going to have a little more Z80 fun time because I'm stumped on that PS2 Model 25 with that Genesis PC board in it. It's very demotivating, so I'm going to set it aside for a little while until I can go back to it fresh, and then I'm going to record another video about it that explains in great detail everything that I've tried and what is going on with various signals on various of the chips. And then hopefully you guys can clue me in with the old clue hammer, and I'll post it over on the Vintage Computer Federation forums too, and maybe somebody there can bash me with the clue hammer too. But in any case, Z80 fun time in the meantime. So here's our Z80 CPU. I put a label on top of it so I could remember what the fuck was what pin-wise, and we've got it strapped up exactly the same as we did before. It's strapped to power and ground how it's intended to, and it's got some bypass capacitors on there. Interrupt, non-maskable interrupt, bus request, and wait are all strapped to 5 volts so that they don't interrupt execution in some way. And the reset line is pulled high through this 10K resistor here, and then it's also just plugged into ground here to keep it low. So when we apply a clock to it, it'll stay in reset until I pull this out of here, and then it'll start executing. So that's the plan there. Down here is a 28C64 electrically erasable PROM. That's a 2K, I think. No, 8K, sorry. The 8K PROM. And we'll write a little bit of software to test some stuff. I'm going to hook an LED up to the I/O request line, so we'll just make a great big loop that makes an I/O request, then runs a delay loop to make it pause for a while so we can see what's going on, and then just keeps doing that over and over again. And we'll run it on a slow clock, and then hopefully we'll be able to see that I/O request LED like go out repeatedly. Since it's active high, it'll go out repeatedly instead of coming on repeatedly. And that'll tell us that shit's actually working. And then we can move on to interfacing this SIO chip to the I/O bus and go through this MAX 232. That's a serial I/O chip. We'll go through the MAX 232 to convert it to RS 232 line levels, and then we can plug it into one of those serial terminals over there and have, honest to God shit going on. Here is a 74LS00 quad 2-input NAND gate that we'll be doing all of our memory address decoding with. And here is a 2K static RAM. It's a UM6116-2, and we'll decode the address space for both of these with just this NAND gate. So obviously we won't be using the entire Z80 memory map. We could write an I/O request like LED flash function in Z80 assembly language if I was more comfortable with that. But I'm pretty sure that SDCC, which is what I intend to try this with first, is probably going to require a little bit of RAM just to set up its stack and shit when it starts. So we might as well just go ahead and put a little bit of RAM on it. And of course up here is the ESP32 module that we'll be using for a clock generator. I don't have any of the gates or the pot hooked up to it or anything like that. I'm going to try to just drive the clock on the Z80 straight off of 3.3 volt PWM signal off of this thing, and then we'll just reprogram it if we want to change the clock speed. Kind of lame, but it's a good way to make it run really slow and then make it run really fast, like speed it up to like 4 megahertz or something to actually run stuff at full speed, because once we hook this SIO chip up there, we'll have to generate some serial clocks for it too and shit like that, and I don't have the right crystal for that, so we'll have to use the thing then. So anyway, yeah, and down here this is a 22 V10 gal, and once things start to get a little more complicated, we'll replace all of our memory and I/O decoding logic with some code burned into that gal. So that's the plan anyway. Hopefully none of the magic smoke will come out, but for the moment I'm going to have another bedtime beer and hit the sack, and assuming that we don't get another 17 feet of snow tonight and I spend all day and all evening digging the cattle out again, hopefully tomorrow will be a little less busy and we can actually get into some fun stuff on here. Alright, see you later.